cloud. So here the record that I have provided in the Western Online. What happened last time when I was teaching the class, when I give you 5 minutes break, I paused the recording, and then when I start the class again, I forgot to hit the record button, and then rest of the things was not recorded. Okay, so the materials that I have today, it is enough. So let me start again some of the materials I'm going to discuss, and then these materials will be done by today. Your responsibility is to read these 7 pages thoroughly, watch the video that are already in the week 5 and the video that will be in the week 6. And then by this Sunday, 11:59 p.m., you will have an exam of 10 questions. Clear? By this Sunday, okay? By this Sunday on this material, okay? So how many pages? 7 pages. 7 pages. You always think a lot. Okay. 7 pages PDF document. You read it thoroughly. Maybe take a printout from somewhere. Go to your room. Sit in the couch. Read it with cool temperament. Watch the video. Try to understand that. Those questions will be technical for you. Understand? Because by Monday, 4:30 p.m., I have to report about your grade to the university if any students are in danger. Understand, right? Good. Thumbs up. Okay. Any question, comment, problem?
Yes, yeah.
Yes.
So we have to do it on Sunday itself, or you will post it and we have to do
It is online. It is online.
Okay.
It is
So
online.
We can do it before Sunday too?
Yeah, before Sunday you can do this.
Okay.
Okay. Maybe I am going to post it tomorrow or maybe today, tonight. Okay. Exam I am going to post it by Sunday 11:59. We will finish it. And next Tuesday there will be class. Okay. So I want to teach you more materials. Ready? Everyone ready, right? Where is the pen? Here is the pen. So last video I stopped in longitudinal data. Longitudinal data. I stop in there. So longitudinal data are 2 types. One is called the balanced longitudinal data, and another one is unbalanced longitudinal data. Longitudinal data has another name. It is known as the panel data. Okay, panel data. So what are the longitudinal data or panel data? If there is a repeated measurement, if there is a repeated measurement of a subject, measurements of subjects, then the data is called longitudinal data. Okay, then the data is called the longitudinal repeated measurement. Suppose all of us, our measurement, height, weight, body mass index, triglyceride, cholesterol, systolic blood pressure, diastolic blood pressure are taken today, and next week again, and then week after next week again, then the data is put together, then that is called the longitudinal data. What is balanced longitudinal data? The balanced longitudinal data means suppose there are 1,100 subjects. Suppose there are 100 subjects. That means 100 person 1, person 2, person 3, up to person 100. Okay. So each of these persons is taken measurement 5 times. First measurement M1, second measurement M2, third measurement M3, fourth measurement like this, fifth measurement like this. So 100 I have taken their measurement. First one has 5 measurement, second one has 5 measurement, third one has all 5 measurement, 101 has the 100 person has the 5 measurement. So each person will have a same number of measurement, then that data is called the balanced longitudinal data. Clear? each person should have a same number of measurement. On the other hand, if the that data does not have the same number of measurement, for example, this measurement is missing, that measurement is missing, that measurement is missing, this measurement is missing, but that does. So in this case, the second person has a third measurement missing, second person has a third measurement missing, third measurement missing, second person has a third measurement missing, third person has a first measurement and third measurement missing. So first person has a fifth measurement missing. So that means some person has a 4 measurements, some subject has a 3 measurements, some subject has a 5 measurement. This type of data is called the unbalanced longitudinal data. Okay. Now come here. After this, cross-sectional data means what? At Western Illinois University, suppose there are 7,000 students, I randomly pick like 500 students. Okay, cross sections. So all the students is in there. I said I want to take like these cross sections. Okay, that is called the cross-sectional data. So cross-sectional data or a cross-section of a study population in statistics and econometrics is a type of data collected by observing many subjects, such as individual, firms, countries, or region at one point or period of time. For example, if you want to measure current obesity level in a population, we could draw a sample of 1,000 persons randomly from that population. Measure their weight and height and calculate what percentage of that sample is categorized as a obese. So that is called the cross-sectional data. Now, spatial and temporal data. Spatial and temporal data. Spatial and temporal data. Temporal data. This coming from the word space. This coming from the word time. Okay. So if data is collected from Ohio, Indiana, New York, New Jersey, Washington, DC, Minneapolis, something like that. So data is coming. So temperature is taken from each capital of 50 states in USA. Each capital means space. And then if I mention that at 9 a.m. So each capital of the 50 US states, and at 9 a.m. the temperature data is taken. Then that data is called, will be called spatial and temporal data. If your data has a space as well as time, then it is called a spatial and temporal data. Okay. Spatial and temporal data is that. Time series data for GDP data. USA has a GDP, right? For the last 60 years, 70 years, GDP is coming by the year. So that is called the time series data. Stock exchange. If you take a look at the New York Stock Exchange now, you see Tesla price is given by day, by month, and then by week, by year, something like this. Understand? And each day you have a highest stock price and lowest stock price. Each day you have a closing price and beginning price. At 9 a.m. what was the price, stock price? At closing, what is the price? So this is given you in terms of the time. The data that is collected in terms of the time is called a time series data. What is the business analytics definition? Business analytics refers to the skill, technologies, and practices of continuous iterative explorations. Iterative means your data came last evening, and then next morning you come, you analyze the data, you give a report to your manager, iterative procedure. And then again, 5 p.m. data came, and then the algorithm was running there, morning you came, and the program that you have written, the program was running, and then you generate a report and give it to the manager. At 11 a.m. So this is the yesterday results. Okay, iterative procedure. Every day you have to do some kinds of work. That is called the business iterative exploration and investigation of the past business performance to gain insight and derive business planning. This is called the business analytics. Definition. What is the definition of descriptive analytics? Descriptive analytics refers to a process whereby historical data is interpreted to understand changes in business operations. Descriptive means I need a description. So that in order to get the descriptions, you need a historical data. From the historical data, I am getting these descriptions. So remember this thing. So what is prescriptive analytics? Prescriptive analytics is a process that analyzes data and provide instant recommendations on how to optimize business practices to suit multiple predictive outcomes. So prescriptions, doctor write the prescriptions, right? Right? If you go to the doctor, doctor write the prescriptions, right? Immediate measure, immediately doctor want you to get rid of the disease, right? So similar types of pattern. Prescriptive analytics is a process that analyzes and provides instant recommendations. Doctor gave you instant medications. Doctor gave you instant, what is called? Antibiotic, right? Doctor said that no, normal medicine will not work for you. You have to take some antibiotics, right? And antibiotics over the counter antibiotic is not possible, right? Doctor have to raise the prescriptions. So prescriptions means immediate. So that is a prescriptive analytics means provides instant recommendation on how to optimize business practices to suit multiple predictive outcomes. Okay. Now, these quartile things I already discussed to you. Let me open again. Anaconda, here is my friend. I will show you today the graphs and how to use like normal curves, empirical rule, Chebyshev rule, those things. Okay. Open, downloads, basic computation, part 1. Basic computation is part 1. Okay. So now you want to learn what is summary statistics first. Summary statistics. Okay, quartile summary statistics, right? So quartiles. So suppose you have a data 17, 19, 5, 6, 15, 12, 7, 11, 9, 17, 25, 20, 21, 18, 14, 15, 19, 16, 17. These are the data. Okay. If data comes like that way, I need to arrange them in ascending order. Remember, arrange them in ascending order. Ascending order to get summary statistics. Summary statistics. Okay. So ascending order. What is the lowest value in here? Maybe 5. I put there 5. And then 6. 6. And then I got here 7. I got here 7. Then I got here 9. 9. After 9, then I got here 11. 11. And then I got 12. 11, 12. Then I got 14. And then I got 15. 115, 215. 15, 15. And then I got 16. 16. And then 17, 17. 17, 3, 17. 17, 17, 17, 3, 17, and then I got 18, 18, and then I got 19, 18, 19, and then 20 I got.
It's still 19.
There is another 19?
Says-
Okay. $19, and then there is a 20, then 21, and then finally 25, right? Okay. Any data, if you are asked to find the summary statistics, arrange them in ascending order, find the middlemost value, that will be the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that means put 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my median. That is called the middlemost value M2. Okay? Or not M2, it's called median. It's called median. It's called median or Q2, second quartile. So median divides the data two equal parts. Below there are 9 observations, above there are 9 observations. So this is the median. Median or middlemost observations. Okay. Then after getting that, this is called the minimum. Minimum. That is called the maximum. Okay. So now I have to consider the middle of this. Okay. And then I have to consider the middle of that in order to find the median. That will be the first quartile. So how many is in there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means these two, 11 and 12. 11 and 12, their average is 10.5. So this is my first quartile. Okay. And then 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. Am I right? 1, 2, 3, 4. 1, 2, 3, 4. So 1, 2, 3, 4. 1, 2, 3, 4. So median of this is 18.5, which is equal to third quartile. Now explanation. Now listen carefully the explanation, okay? 75% of the data lies below 18.5. That is called the third quartile, or 25% of the data lies above 18.5. Understand? Clear, right? Similarly, 25% data lies below 10.5 and 75% data lies above 10.5. That's the way quartiles are explained. What is the definitions of the quartiles? Quartiles divides the data in 4 equal parts. First quartile, second quartile, third quartile, 4 equal parts. How? First 25%, and then this is called another 25%, between 25% and 50%. This is third 25%, between 50% and 75%. This is the top 25%, above 75%. Okay? Yes. Yeah, right. You are right. It is 11.5. That is 11.5. Okay. So now, what is mod? Mod is the value. Mod is the value that appears highest number of time in the data. Value or values that appear appear highest number of times in the data. Okay? So what is our mod in this case? Can anyone of you tell me what is mod? 17, right? 17 is the mod that appear highest number of time. And what is mean? Mean equal to sum of all of these, right? Divided by
How many numbers?
19, right? So that means 5 plus 6 plus 7 plus all the way up to 21 plus 25 divided by 19 will give you the mean. Clear? So these three measures is called the measure of central tendency. Mean, median, and mod are called measure of central tendency. Central tendency. So they are measuring the central of the data. Understand? These three measures are called the measures of central tendency. Mean, median, and mod. Okay. Now, most important question, standard deviation. Standard deviation. It has a formula like this. This is the formula for the standard deviation. Okay. So this is the formula for the standard deviation, and square of this is the square of this is known as the variance. So what is variance? Variance is just this. This is known as the variance. Okay. So what is the meaning of this? How can I explain these things? I have to explain this quantity so that you can understand. Okay. Take a look. How can I explain these things to you? Last time I already discussed these things. Let me discuss these things one more time. So this is a group 1, that is a group 2. This is a group 1, their score in an exam is like this. And another group of students, their score is like this. 1. Clear? So their average which is denoted by X bar equal to 50, and their average which is equal to Y bar, this is equal to 50, right? Their mean. Right? Suppose now I want to block these things like that way. If I block these things and just give you the mean, can you make any decisions? I just want to block these things. Blocking is not working. Blocking is not working. Okay. Suppose the individual levels of scores are not known to you. And if I give you just the average, you said that, well, Dr. Chaudhary gave the average score for the two groups. What can I say that? I can say that both groups are the same. Both groups are at the same level, right? But if I give you individual level of scores, then you see that, well, individual level of score, one group consists of an average number of students and another group consists of extremely good and extremely bad students, right? The exam was conducted in a scale of 100. Yeah, right? So once you see the individual score, then you can immediately make a decision. But the problem is where? The problem is that this is just the 4 data points, then immediately by visual inspection, you can make a decision. But instead of 4 data points, if there are 500 data points, it will take a lot of time, right? Right? Instead of 4 data points, if there are 500 data points, it will take a lot of time because you have to go through this. So how can I make a decision without going through each data point? Standard deviation is the answer. Understand? Without looking at the each data point, how can I make a decision that which data is more consistent between the two? Standard deviation is the answer, right? So standard deviation is the answer. Why? Because when I find the standard deviation, I will find that their standard deviation is very low. Top one standard deviation is very low, bottom one standard deviation is very high. Then I can say that, well, this is a standard deviation is very high. So that means that data is not consistent because this data is deviated from the mean and their standard deviation is very low. So this is a consistent data. So that's the point. For example, if I want to use this formula in here, what I will get in there? So 4 minus 1 equal to 3. Then I will get there 50 minus 50 square plus 49 minus 50 square plus 51 minus 50 square plus 50 minus 50 square. So now if I find this value, we will get some value in there. On the other hand, if I write here like this, then I get 100 minus 50 square and 0 minus 50 square, 99 minus 50 square, and then plus 1 minus 50 square. Clear? So now if you compute these things, you will get the result. Last time you reported, one of you told me what is the value. So let me see if it is in there. No, the results I did not put it in there. Okay, I will add that things in there. So that value we will get, okay, let me, what time, 4, like we have 2 more hours. So let me compute these things quickly. Let me see. If I want to compute it in here, 2/3, square root of 2/3, right? Let me see, import numpy as np, numpy as np, and now np dot sqrt square root of 2/3. So 0.81. 0.81. So here is 1. Here is 1. 1 square equal to 1. So 2/3. Square root of 2/3. Okay. So now I want to find again. 3 is fine. Let me check what we have in the upstairs. Upstairs, what we have? We have 50 square, which is equal to 2500. 2500 plus again 2500. 50 square, 2500. and then 49. Zero minus 50, 100 minus 50. 49, sorry, one is, yeah, 49 square, 49 square. What is 49 square? Plus 49 times 49 plus 49 times 49. Right? So now 57. We got 57 in there. Are you understanding? 57 point what? 57.16. 57.16. Clear, right? So now, without looking at this data, by looking only at the mean, anyone on the planet will say that, well, as their average is 50-50, both group are the same. But if there is a good statistician, he can ask, can you also provide the standard deviation of these two groups? If the standard deviation is provided, the person say that one group data is more consistent, which means data is staying around mean. And other group of data is spreading out, way out from the average. In this case, data 0 is way spread out from 50. 1 is way spread out from the 50. 100 and 99 is way higher than the 50. On the other hand, 50, 49, 51, 50, they are around 50. So what does standard deviation tells you? Standard deviation tells you how consistent your data is. Understand? If I send hard for data collection, if I send this guy for the data collections, how much money the university student spends for their lunch, and hard data, the mean and standard deviation, mean is $10, standard deviation is 0.5. Hard data, this data, mean is 10, but standard deviation is 20. So that means he went to the people who ate a lot or maybe eat in an expensive restaurant. Understand? So that's the way you have to explain. You understand, right? So now what is the explanation? Explanation is this. Let me explain. Take a look at the data. This is the distance of each data from its average. This is the distance. Okay? Average distance of each data from its average is called the standard deviation. Okay? Average distance of each data from its average is called the standard deviation. Average distance of each data point from its average is called standard deviation. Understand? Average distance of each data from its average is called the standard deviation. Average distance. Why? This average distance, this average stands for 1/3. 4 observations, but there were 1/n minus 1. Why? Because that is coming from the concept of unbiasedness. From its average means this one. From its average means that one. From its average means this. And average distance means dividing it by that. Okay. So I hope you understand the definition of standard deviations. Now, I want to find that covariance. Covariance is defined by xi minus x bar, yi minus y bar. This is the covariance formula. Okay. So covariance is joint variability. Joint variability. Joint variability of two variables is called covariance. Joint variability of two variables is called covariance. Height is increasing, weight is increasing up until a certain age, right? After age 20, it is very rare that people height will go up after 18, something like this, okay? If price is increasing, demand is decreasing, right? Price is increasing, demand is increasing. If demand is increasing, price is also increasing, right? Demand is increasing. That is why during the summer, we see gas prices goes up, right? All summer, gas price go up. So supply and demand and price and demand. This is so covariance formula is written at covariance of x comma y, and it has three types of value. It has greater than 0, equal to 0, less than 0. These three values you can obtain from covariance. Okay. These three values you can obtain from covariance. Let me check the values of the covariance. Okay. So what I did here, I make a mistakes in there. This should not be in there. Covariance. I should be careful about that because I'm saying covariance. I'm not saying co-standard deviation. Actually, there is no concept of co-standard deviation. Understand? No concept of co-standard deviation. No concept of co-standard deviation. Why? Why there is no concept of co-standard deviation? If co-standard deviation is in there, square root is in there, then the problem will be, let me explain, the problem will be, if suppose there is a concept of co-standard deviation by plugging, suppose this is a co-standard deviation, which is like that, then what will be the problem? Can anyone of you tell me what will be the problem? There is no concept. There is no concept of co-standard deviation. What will be the problem? The problem is if this becomes negative, this become negative, this become positive, then multiplication negative times positive equal to negative, then under the square root there is a negative, then it will be what? Imaginary. Under the square root, if there is a negative 4, that has a name. This is called the complex number or imaginary number. Complex number or imaginary number. Imaginary number, IN. Imaginary number. Understand? So that is why there is no concept of co-standard deviation by putting a square root sign under the covariance formula. Clear? Okay. So covariance could be positive, covariance could be 0, covariance could be negative. So if covariance could be positive, then figure would be like this. One is increasing, another one is increasing. Covariance is positive like this. Okay. One is increasing, another one is also increasing. If covariance is negative, then figure should be like this. One is increasing, other is decreasing. One is increasing, other is decreasing. So this is the point, this is the point, this is the point, this is the point, like this. Okay. So this is decreasing, X is going down, Y is in here, Y is going up. If one increase, other decrease, then this is the type of graph you will find. On the other hand, if covariance equal to 0, then your graph should be like this. Here is X, here is Y. Change in X does not affect the change in Y. Changes in X does not have effect on the changes in Y. So that means you will get a circular figure like this. You will get a circular figure like this. Clear? You will get a circular figure like this. So what is the limitation of covariance? Limitation of covariance. Covariance cannot tell how strongly, so let me write it in here. Covariance cannot tell how strongly or weakly let me write here positively or negatively, two variables are correlated. Covariance can only tell you two variables are positively correlated, two variables are negatively correlated, but they can never tell you how strongly positively. Understand? How strongly positively, how strongly negatively, or loosely positively, loosely negatively. You understand the word, right? Strongly positively. Strongly positive means 1 unit increase, 1 unit increase, 2 unit increase, 2 unit increase. Very strongly, perfectly correlated. Understand? So that thing we cannot say. We just from the covariance we can just simply say two variables are positively correlated or two variables are not correlated if covariance value is 0 or two values are negatively correlated. But I cannot say they are strongly positively correlated. We cannot say that. They are strongly negatively correlated. We cannot say that. Understand, right? Okay. After discussions of this covariance, there is another measure that is known as the coefficients of variations. Coefficients of variations, sometimes covariance is not enough because I have a covariance of between two variables in here and covariance of between two variables in here. Those two variables covariance is not enough to measure their relative covariance. So that is why coefficient of variations is come in here in order to express that in a different measurement scale. So it is defined as the ratio of standard deviation to mean. Suppose X is a variable, I want to find the variations of the standard deviation with respect to its average. So it shows the extent of variability in relation to the mean. So this is the standard deviation, which is the average distance of each data from its average. So I am expressing now like variation with respect to its average. So that is why try to understand why this concept is important. It is defined as the ratio of standard deviation to mean, which is like this. It is ratio. But why we need it? Why? What is the rationale? I have to give the rationale. Rationale is saying it shows the extent of variability in relation to the mean. So I want to find the extent of variability of that variable in relation to the mean, like variability in relation to the mean. It is sometimes expressed as a percentage. It is denoted by CV and defined at that. So if I put here 100, excuse me. Thank you. If I express it in terms of percentage, then between two variables, I can express their variability with respect to their mean. Understand? For example, let me tell you. America has an income. My country, Bangladesh, also has an income. So income in the people of Bangladesh are not in the level of the United States. Are you understanding? So, but now I want to compare the income variability between two countries. So if you directly find the standard deviation of Bangladesh, directly find the standard deviation of United States, that scale is different, right? Are you understanding? But if you express them express their variability with respect to their mean, then it will be adjusted. Understand? So then you can say that, well, coefficient of variation Bangladesh is this, coefficient of variations in USA is that. In that case, standard deviation USA definitely be higher in compared to Bangladesh. But if in terms of coefficient of variations, it could be Bangladesh could be higher, America could be higher. Because variability is measured with respect to its average. Do you understand? Each time, please, each time you read something, after reading something, give a pause. Think about this. Why they are doing these things? Give a pause, think about this. Why they are doing these things? Why you are doing these things in here? The rationale is this. Rationale is this. It shows, come. What happened? Okay. I don't know why it is not giving me permission to write in there. I should have a authority to write in here. Now, let me conclude these things by telling you, suppose I ask this girl, go compare the standard deviations of the income of the people of US and Bangladesh. And USA, it is yearly income, 60,000, 70,000, something like that. Okay. But Bangladesh, if you go in terms of US dollar, it could be maybe in whole year, it could be maybe 12,000 or 11,000 or maybe 10,000, right? So if you compute the standard deviation of US income with the standard deviation of Bangladesh income, then that income would not be comparable because the scale is different. Understand? But if you compare them in terms of coefficient of variations, because variability is measured with respect to its mean. Variability is measured with respect to means. USA income variability divided by USA mean. Bangladesh income variability divided by Bangladesh mean. Then you can compare. Yes. Now you understand?
I was asking if you compare to a mean of the two or then you answer.
In that case, even if you compare mean of US and mean of Bangladesh, then even it is like a comparison could be possible. Well, Bangladesh people average yearly income is $15,000, but USA average income is $80,000. That could make sense. But in terms of variability, if you try to compare between these two, those income and that income is not in the relevant scale. But if you compare variability with respect to their standard deviations, then it makes sense. Okay. Statistical graphs. Okay. Statistical graphs. 4 graphs we will discuss, then we will discuss 2 other measures, then we are done. Statistical graphs. So variables. So qualitative variable, qualitative variable. It has 2 graphs. One is called the pie chart. Another one is called the bar chart. You already constructed this and did the homework and submitted it, right? This is what you have done by using Python, right? But how can you do that? Suppose we have these things. African American. Okay, let me write it in different format. African American, Caucasian, Latino, African American, Caucasian, Latino, Caucasian. Then I want to put here Mongoloid. So when we are like 6th grade, 7th grade, we taught this. These are the race, human race: Mongoloid, African American, Caucasian, Latinos. And then let me put here again African American, Caucasian, Latino, something like this. Okay. So how many Latinos is in there? 1, 2, 3, 4, 5, 6. 6 Latinos. How many African American? 1, 2, 3. 3 African American. And how many Caucasian? 1, 2, 3, 4, 5, 6, 7. And how many Mongoloid? Just 3. 3, right? Mongoloid equal to 3. So now, if you want to do the bar chart, you can put here, this is equal to 2, 4, 6, 8. So you can put a bar chart for Latino. Latino one is 6. You can put here up until in here. This is for the Latino. You can put here L. And then African American 3. You can put here like this and that. This is African American. And then you can put here Mongoloid 3. You can put here like this. And then this is Mongoloid. And then Caucasian is 7. You can take here up until in here and then come in here. This is called the Caucasians. So in the x-axis, you can put here race. Y-axis, you put here frequency. That's the way you can construct bar chart. So when we are undergraduate students, almost 20 years ago, we did these things by using paper and pencil approach. This is called the bar chart. Now, how to do the pie chart? Pie chart, in order to do the pie chart, you can do this like 13, 19, n equal to here 19, right? N equal to here equal to 19%. So we want to express this 19% as 100%. So n equal to total number of observations. Total number of observations equal to 19. So now I want to find here ratio or percentage of Latino. Percentage of ratio. Percentage of ratio. Percentage of ratio for what? For Latino. Latino, there are 6 out of 19 times 100. Can someone of you tell me what is that percentage? And then African American, 3/19 times 100. African American, Caucasian, 7/19 times 100. And then Mongoloid, 3/19 times 100. Okay, tell me.
Is 31.5.
31.
Yes, 31.5
Okay, then African,
is 15.7,
then
36.8.
36.8, and that one is 15.7.
Yep.
So if you add them up, you will get 100%, okay? This plus this plus this plus equal to 100%, right? This is all of this equal to 100%. So now if you do these things, I want to draw a circle. Okay? Then circle you can say that, well, 36%, right? This is 100. So you can say that this will be 36%. So this is 36%, which is equal to Caucasian. C equal to 36.8%. Okay? And then there is a 31%. 31% you can say that could be 31%. 31% equal to Latino. 31.5% Latino. And then remaining 2 is 15%. 15.7 equal to African, and 15.7 equal to Mongoloid. Okay, now you can put a color like this. You can put another color like this. Pink one. Mongoloid. Oh, that black black color make that percentage disappear. So that's the way you can do the bar chart and pie chart. Okay. Now you have to learn how to do the histogram and box plot. After histogram and box plot, then we have few other concepts. We have enough time. So in order to do the histogram and box plot, histogram and box plot. Histogram and box plot. So let me do the box plot one first, okay? Let me do the box plot one. In order to do the box plot, create a box is like this way. Let us do the box plot first. So in order to do the box plot, we have constructed these boxes. So remember the data that I put there. So in that case, my Q1 equal to 11.5, right? Remember, my Q1 equal to 11.5, right? So I put here 11.5 and 18.5. 11.5 and 18.5. This is my 11.5. That is my 18.5. So 11, 12, 13, 14, 15, 16, 17, 18. So 7 unit I put there. So 1, 2, 3, 4, 5. Okay, so I need to erase these things and to make the graph perfect. One, 2, 3, 4, 5. So scaling is not very good, but this is what like this. So this is 12.5, that is 13.5, that is 14.5, 15.5, 12, 13, 14, 15, 16.5, 17.5. This is my Q3. This is my Q1. Okay? You got it, right? Box plot I'm constructing. Now, I have to find my median, which is equal to 16. Median equal to 16. Median equal to 16, which is in here. 15.5, 16.5, 16 is in here. So that is my Q1, Q2. That is my Q2. It should be in the scale. It is not just randomly draw a box and then you are saying this is my Q1, that is my Q2. It will not work that way. I put the box and then after putting the box, I put one as a 11.5 and another on 18.5 and then I make the space equally as much as possible. So that the scale should be the same. Clear, right? Listen carefully. Now, most important task. Now, we have to draw whisker. Now we have to draw whisker. After drawing whisker, then box plot is done. After drawing whisker. In order to draw the whisker, we have to do some computations. IQR, it is known as the interquartile range. Interquartile range, which is equal to Q3 minus Q1, which is equal to 18.5 minus 11.5, which is equal to 11, 12, 13, 14, 15, 16, 17, 18, which is equal to 7, right? IQR. Now we have to compute lower inner fence. Lower inner fence. So lower inner fence, how can you compute these things? Q1 minus 1.5 times I QR. So my Q1 equal to 11.5 minus 1.5 times 7. Can any one of you tell me what is this one? And then up lower inner fence, upper inner fence. Upper inner fence Q3 plus 1.5 times IQR, which is equal to 18.5 plus 1.5 times 7. Tell me this number, first one.
1.
This is 1. That one? 18.5. What is that? No, 18 point, this is 8.
Oh, I did 2 minus. That's not fun. 29.
29?
Yeah.
29. Okay. Clear, right? Everyone ready? Okay, if you are ready, let me delete something in order to make the picture beautiful. Okay, take a look what I am deleting in here. I just want to delete these things. Okay, let me go there first. This is equal to 18.5 minus 11.5 equal to 7. And then I want to delete these things because I need a space in there. Okay? Are you ready? Okay. So I got a lower inner fence which is equal to 1, which could be, then it will come here 11.5, 10.5, 9.5, 8.5, 7.5, 6.5, and then 5.5, 4.5, 3.5, 2.5, 1.5, and 1. Suppose this is equal to 1. Are you understanding? Are you understanding? And similarly, it will go 29. Suppose this is equal to 29. Clear? So now draw the whisker to the maximum of the data within the upper inner fence. So what is the maximum of the data? What is the maximum of the data? 25, right? See, let me write it so that you will not forget if someone asks you. Draw a line or whisker cat has a whisker, right? Draw a line whisker to the maximum of the data within the upper inner fence. I'm going to ask you a question after drawing this. Now draw a line to the minimum of the data within the lower inner fence. What is the meaning of this? Draw a line whisker to the maximum of the data within the upper inner fence. Draw a line to the minimum of the data within the lower inner fence.
So you have the box plot, right? Would you draw a line from the Q3 until 25?
25, yes. I will go and stop in here. Okay?
Then you just do the opposite for Q1.
Yes. So that means, what was the lowest one?
I think it was 5.
It was 5. We have to stop in here. And it should be scaled. It should be exactly scaled. So this should not be 18 to 29, 25, 18, 19, something like that. It should be scaled, understand? It should be purely scaled. Okay. Now I want to ask you a question. Suppose maximum of the data is 34. Suppose maximum of the data is 34 and minimum of the data is 0.7. How far I can take my whisker now? Suppose the data that I have provided, minimum is 5 and maximum is 25, right? Now suppose in the data, minimum is 0.7, maximum is 34. How far I can take my whisker? What? Up until 1 and 29, yes. Not up until 1 and 29. I have to take it up until 25 and up until 5. That is why I write there. Take a look. She said, draw the line up until 29, right? She said, draw the line up until 29 or draw the line up until 1. No. No. The answer is this. Draw a line to the maximum of the data within the upper inner fence. What is the maximum of the data? No. Take a look at it. Draw a line, a whisker to the maximum of the data within the upper inner fence. Within the upper inner fence, what is the maximum? 25. You understand now? She is a little confused. Could you explain this to her? You understand or not? Not kind of. Who can explain these things? Do you understand?
I don't know to explain them. Yeah, I don't know enough to explain.
Okay, let me explain. That is why I purposely write this sentence. Draw a line whisker to the maximum of the data within the upper inner fence. What is the maximum of the data within the upper inner fence? That is 25, right?
But you said we changing the maximum and the minimum to 1.7.
Yes.
So that means there was no 20, let's just see there's no 25 and 5 again. Is
So-
that what you're saying?
Yeah, so you cannot take your whisker to the maximum of the data that is outside the upper inner fence. That is outside the lower inner fence.
So we would take it to the next number in.
Yeah, so draw a line to the maximum of the data within the upper inner fence.
Okay, so it's within the range from Q3 to the like upper inner fence, right? The highest number. between
Yes,
that
yes,
range. Okay.
yeah. So within that, so that is why within the upper inner fence, within the lower inner fence. People make a mistakes, what they do, they start drawing up until the maximum. But if up until the minimum, if minimum value is way smaller than upper inner fence, you cannot take it in there. For example, now our lower inner fence equal to 1, but I say in the data minimum is 0.7, then they can say that, well, take it to the minimum 7. No, that is the lower inner fence. You cannot go outside of that.
Okay.
Any number that falls after this whisker is called as an outlier. So number down the 29 will be called as an outlier. If there is a observations 29 in the data, then it will be called as a outlier. Okay, take a look at that. In computing lower inner fence and upper inner fence, I am not using like maximum or minimum. Lower inner fence is computed by using Q1, Q3 and interquartile range. So the maximum and minimum value are not used at all in drawing this figure. Understand? In drawing this figure, we need 4 quantities or maybe 5 quantities. Yeah. First quartile, second quartile, third quartile, interquartile range, lower inner fence, upper inner fence. These 6 quantities are needed to compute these things. Even like some people read those things, they do not understand how these things is computed. They are dragging their line up until the minimum value, up until the maximum value. But you cannot draw the whisker to the minimum of the data within the lower inner fence. Draw the whisker to the maximum of the data within the upper inner fence. So minimum, maximum are not used at all for computing interquartile range or lower inner fence or upper inner fence. Any value that fall outside this whisker is called, suppose 29 is in here, now 29 is the outlier. Now 1 is in here, 1 is the outlier. Understand? You are confused, you look like.
I know enough.
Okay, so could you please come here, take the professorship position, please.
So, do you care if I write on it?
Yeah, you can write.
Okay. So the way I think of it. How do I move it? Oop. How do I move it? Like the paper up?
You want to delete it?
Yeah, but like, how do I move
Or
the
you use
paper?
use this one, mouse.
Oh, okay,
Go.
okay. So when you're drawing a box plot, you obviously have your box and you have your line. So when the range is 29 and the range is 1, we don't really care about the numbers outside of that range. So if a number falls outside here, we don't care about it. So as long as it's between here and here, we care about it. Does that make sense a little bit? Yeah, so if it's outside, we don't care about it, it's called an outlier. Kind of think of it like a bar or just a normal graph. And if the graph is here, we don't care about if there's a data point out here. Does that make sense? Okay.
Yeah, so what she told you. In this case, take a look at that. This is our data. In this case, interquartile range is computed by using Q3 and Q1. Minimum and maximum was not used, right? What is the lowest value, what is the highest value was not used, right? Interquartile range is computed. And then lower inner fence is computed by subtracting 1.5 times interquartile range. We got this value 1, and then upper is 29. So this is the upper inner fence, this is the lower inner fence. Now I write this sentence in here. Draw a line, that means we start to the maximum of the data. So original data that I mentioned, original, within the upper inner fence. Within the upper inner fence, maximum data is 25. So I stop in the 25. I stop in the 25. Now the question is, if there is another data, suppose 27, then I have to take it to the 27 because that 27 within the 29. But if there is a 34, I cannot take the line to up to 29. I cannot take the line. For example, suppose there are 25, right? Suppose there is another value 27. Then I have to take it up to in here, 27. I have to stop in there. Suppose there is a, then I have to delete these things. This is the 27. 27 in here. Understand? Look like you are confused.
I have a question like this.
Yeah, you have a.
Are you saying that if the value is 27 and we have 25, you can erase 25 and draw it to 27?
Yeah.
Oh, okay.
So that means in the original data, suppose original data lowest value is 5, right? Lowest value is 5, original data. But now suppose original data lowest value is 3. I have to take it to up to 3.
Oh, okay.
Okay. That is within 1. That is within 1, right? What is 1? 1 is the lower inner fence. But if there is a value which is equal to 0.9, I cannot take it to the 0.9 because 0.9 is outside the 1. Understand now? Draw the whisker to the, that is why these two sentences. Draw the whisker to the maximum of the data within the upper inner fence. So when I was doing PhD in George Washington University, so I was trying, because during that time my English was not very good, but I already did my 2 years study, I already taught classes. So it takes a lot of time to clarify the idea. Anything that falls outside that whisker value is called the outlier. For now suppose you stop in here, right? You stop in here because there is no 3 or nothing. So you stop in here, then anything that fall outside that that whisker, these things is called the outlier. So in my cases, 29 will be outlier. If 29 will appear there. No, 34 will be outlier. 34 will be outlier. Okay,
Just to make sure. So if the data point was 3 and 0.7, where would it better be applied to?
sorry.
If the data point was 34 and 7, where would you put all those 32?
So data point is 34 and 7, right?
0.7.
Okay, so highest value is 34 and lowest value is
What should be 0.7?
0.7, right? What is my upper inner fence? 29. What is my lower inner fence? 1, right? So she said in the data sets there is the 34 is the highest value and lowest is the 0.7, right? Or can I? So lowest is the 0.7. I have to take it to the maximum within the lower inner fence, which is equal to 5. And then I have to take it to the maximum of the data within the upper inner fence, which is equal to 25. So now 34 falls in here and 0.7 falls in here. This is the outliers. Clear? Now, suppose in the data, there is a value 28. Now take a look at that. In the data, highest value is 28, lowest value is 2. How can I draw it? I drag it to up to 2. Understand? Lowest value is 2 in the data and highest value is 28. I have to drag it to 28. Understand now? Do you understand now?
Yeah.
That gentlemen, are you okay? Okay. Now let me do histogram. Same data. Suppose I want to create these 3 things, histogram, right? So I want to do 0 to 5 and then 5 to 10 and 10 to 15 and then 15 to 20 and 20 to 25, 25 to 30. Clear? Same data. This is called the class interval, CI. CI stands for class interval, okay? Same data. Same data, I put here CI and then I put here frequency. Frequency. Okay, can any one of you tell me those numbers that I wrote previously? Uh-oh. What happened? Just a second. Can any one of you tell me the numbers that I wrote? What are those numbers? Nobody wrote down those numbers? Nobody? Did any one of you write those numbers?
Even 17 more.
Yeah, those are the numbers that I wrote. You did not write it? Okay. Because I want to do something in here. Okay, I am remembering 5, 6, 7, 9, 5, 6, 7, 9, 10, 11. Okay, you can take a picture and tell me.
17.
So what is the number?
5, 6, 7, 9.
5, 6, 7, 9,
11, 12, 14, 15.
15,
15, 16, 17, 17.
317, right?
Yes. 18, 19, 19. 20, 21, 25. 5, 6, 7, 9, 11, 12, 14, 15, 15, 16, 17, 17, 17, 18, 19, 19, 20, 21, 25.
25, right? So let me put here few more numbers in here, suppose 26, 26, 26, and then put here 4, 3, 4. That's it, I guess. Okay. 0 to 5, how many? 1, 2, 3. There is 3. And 5 to 10, how many? 1, 2, 3, 4. 4. And 10 to 15, 10 to 15, 1, 2, 3. 15 to 20, 1, 2, 3, 4, 5, 6, 7, 8, 9. 20 to 25, 1, 2, 25 to 4. Understand? This is upper class limit excluding. 5 is not included in here. 5 included in next one. Understand? 5 is included in next one. Okay. So now this is called the frequency table, and then I can find the cumulative frequency table. Cumulative frequency, which is equal to 3, and then 7, and then 10, and then 9. This is 9, right? 15 to 20, 15 to 20. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. So 3, 7, 10, 19, 21, and then 25, right?
Yeah.
25. So now how the histogram are computed? Here we want to put class interval 0 to 5 to 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 30. So 0 to 5, how many? 3. So I want to put here 3. 5 to 10, how many? 4. I want to put here 4. 10 to 15, how many? 3. I want to put here 3. And then 15 to 20, how many? 9. I got this. 20 to 25 equal to how? 2. 25 to 30, how many? 4. Okay. So now this is called the histogram. Understand? And then curve that I have added, it is called the frequency curve. This curve is called the frequency curve, because that curve is obtained from the frequency, right? So top middle point of each bar is connected by a curve. Top middle point of each bar is connected by top middle point of each bar is connected by a line. So that is why this curve is called the frequency curve. Now, previously when I draw the bar chart, the bar are isolated. They are separated. Hispanic, African American, Caucasian, Latinos, those are separated. But here, this is adjacent. They are connected. Take a look at that. In that case, this is separated, right? There is a separation. Each category is different. Okay. But in histogram, they are adjacent. Like, so now here we put the frequency in y-axis, we put the frequency free. In the y-axis, I put the frequency, and in x-axis, I put the class interval. Okay? Clear? So how to draw histogram by paper and pencil approach? This is the paper and pencil approach. You have a continuous data. You have to create a class interval. Corresponding to each class interval, there is a frequency, and then you will draw that. My goodness, where is my? Huh. The Word document disappear completely. I don't know how Word document disappear without having my permission. You see, whatever I have written, everything gone. So you know how to draw box plot, how to draw histogram, how to draw bar chart and pie chart by using paper and pencil approach. Okay. So now let me explain you two concepts. One is called the empirical rule. Empirical rule. Empirical rule. Empirical rule is telling you what? Empirical rule is telling you you have a data and you have constructed histogram. Empirical rule, you have a data, after data you constructed a histogram. So suppose you have like this. And then you have added top middle point of each bar by using this frequency curve. Okay. In order to understand what is empirical rule, you need to put attention to my words. You have a data that is quantitative, that is continuous. You created class interval and corresponding frequency, and then you draw a histogram. After drawing histogram, you add the top middle point of each bar and you connect them by a frequency curve. And then if your frequency curve is symmetric, looks like this way. You understand? You have a quantitative variable, that means continuous variables. You make a class interval and then you make the corresponding frequency table and construct a histogram and add the top middle point of each bar and got a frequency curve that looks like this. This is called the symmetric. This curve is called the symmetric, bell-shaped, mound-shaped, or normal curve. Do you understand? Let me tell you one more times, then I will go for the explanations. You have a data. From that data, you constructed a histogram. You have a quantitative data or continuous data. From that data, you constructed a histogram. After constructing histogram, you add the top middle point of each bar. And then you got a curve that looks like this, symmetric. 50% of in the right side, 50% in the left side. And if you fold that curve by the middle of this, one superimposed over the other, one coincide with the other. That curve is known as the symmetric curve, bell-shaped curve, mound-shaped curve, or normal curve. Understand? And this is called the mean. In this case, mean equal to median equal to mode. Mean, median, mode are the same in such a case. Clear? How did I get this curve? How did I get this curve? Can someone of you tell me? Frequency curve, how did you get the frequency curve? How do you get the frequency curve? From the histogram. Okay? Wherever you will go, someone asks you, how do you get the frequency curve? Immediate answer, histogram. How did you get the histogram? I have continuous data, class interval, frequency. I put the class interval in the x-axis and in the y-axis I put the frequency. I put the adjacent bar and at the top middle point of each bar, I got a curve. That curve is called the frequency curve. Understand? So it is well set in your head what is frequency curve, right? Frequency, that means 100 frequency of the data are within this curve, right? Now take a look at that. Take a look at the board. In this frequency curve, this part is cancelled out, right? So this is the part of the frequency, right? This is the part of the frequency, but this part is cancelled out, right? But that part is included, right? That part is included, right? That was not the part of the frequency. Are you understanding? That part was cancelled out, which was a part of a frequency, but this part was included, right? So now the purpose is, I want to know what percentage of frequency fall below that. Suppose this is equal to -2. I want to know what percentage of frequency fall below 2 or below 3. Do you understand? I want to know what percentage of frequency fall below 1. The scaling is not right in here, but this is what I want to know. That is what known as the empirical rule. Understand? Empirical rule will tell you to know what percent of frequency falls from the frequency you constructed histogram and then frequency curve. Now from the frequency curve, you want to know what percent of frequency fall below that value. What percent of frequency fall below that value? Understand? Are you understanding? From the frequency curve, what you are going to know now? You want to know what percentage of frequency fall less than a value. So now I am going to tell you and write you that formula. Okay, so everyone understood how we got the frequency curve. Okay, so now I'm going to write the formula. Very big one. Symmetric curve, bell-shaped curve, mound-shaped curve I have drawn. So this is a 50% is in here. Okay, suppose this is my mean, which is known as the X bar. Okay, so within one standard deviation of mean. So X bar minus S and X bar plus X. X bar plus S. Are you saying within one standard deviations of the mean? This is known as the within one standard deviation of mean. Within one standard deviation of mean. Within one standard deviation of mean. So that means if you have a data, that data has a mean of 50, you have a data, that data has a mean of 10. So within one standard deviation means X minus S. So 50 minus 10 equal to 40 and X plus X, which is equal to 60. So between 40 and 60, what percentage of data fall, which is in here? This is what I want to put in this format. So between 40 and 60, 68% data false. Do you understand? So this is what I assume. This is what I assume. It could be any. Are you understanding? I assume. This is what I assume. Okay. But what is the main learning? If you have a data, okay, take a look at me. What I am telling you, take a look at me. You have a data. From that data, you can find mean and standard deviation, and you construct histogram, and then you construct frequency curve. Frequency curve looks like bell shape, mound shape, normal curve, and then from mean and standard deviation, if you subtract mean, if you add mean, then you will get two numbers in here. Within that two number, 68% of the data falls. 68% data fall. 68% of the data false. Do you understand these things or not? Do you understand? 68% data fall. Now, within two standard deviations, I want to take different color. Within two standard deviation, which is equal to x minus twice x, and then this is equal to x plus twice s. So within this, %95 data fall. 95% of the frequency. Data falls means 95% of the frequency. This is coming from frequency curve. 95% of the data falls. That means 95% of the frequency falls. I will show you a real life example in a minute, okay? In a minute, I'm going to show you real life example that this is true. Okay, within three standard deviation, let me take another color. Within three standard deviation, x bar minus 3s and x bar plus 3s. Within this, within this 99.7% data false. That means 99.7% of the frequency fall within three standard deviation. But what is the condition? Condition is that you have a data which is continuous data, quantitative data. That data you use to construct histogram and then draw the frequency curve. Frequency curve look like symmetric bell shape and mound shape. Under that conditions, these three data structure falls. Okay, these three data structure fall within two standard deviation. Within three standard deviation. Within three standard deviation of mean. 99.7%, and that one within two standard deviation. That is within two standard deviation. Okay. So now let me convince you by a example. Clear? I have to convince you, right? By real life example. Let me open the R, which you are going to learn as well at the end of the semester. I open the R. This is the R software. Okay. Take a look. I am going to convince you now. So I am denoting this as A. I am doing R norm. I want to take 100 sample that has a mean of 50, standard deviation of 10. I am taking 100 random normal values that has a mean 50 and a standard deviation of 10. So now if I take a look, this is the value. Okay. Now I want to do the histogram of A. Then take a look at that. It looks like not perfectly, but like goes like this way, come like that way, right? Almost similar. It looks like similar. Okay. Now in this case, in this A, I want to short them. Short of A. which is equal to as a B. B is the, I have shorted them. Okay, now I want to compute mean of A minus SD of A, comma, I want to do mean of A plus SD of A. And then I just want to find their value. So the 40.91 to 59.87. Within one standard deviation, I have computed, right? Within one standard deviation, mean minus standard deviation, mean plus standard deviation. The value is 40.91 and 59.87. Are you okay? Now we have to compute what I said 68%, right? I said 68%, right? Now let me compute these things, whether 68% follow or not. This is equal to B. B is the shorted one. Now compute. So it is coming from 40, right? So 40. Here. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68. Okay? 68. And then 69, 70, 71, 71. So that means what percent? Around 68%, right? So 59.81, 59.87. I have to stop in here. This value is bigger than that one. Okay? And then 40.1 starts in here. 40.91, right? So then 40.91 starts in actually here. So my computation was wrong. So now it starts from there. Take a look at that. So 10.
Is that after?
1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 63, 64, 65, 66, 67, 68. Exactly 68. Exactly 68%. Do you understand what I say? What I did? Exactly between these two numbers, exactly 68 numbers is coming from there. It starts in here. It starts in here. It starts in here. It starts in here. And it ends in here. It ends in here. It ends in here. So if you compute this is 1, 2, 3, 4, 5, 6. Did you get it or not? Did you get it or not? What I am showing you, I claimed you these things, right? I claimed you these things, right? Within one standard deviation, 68% data false, right? This is what my claim was, right? So I said, within these 68% data false, 68% data false in this within one standard deviation. And then I have to convince you by a numerical example. What I did, I go to the R, I generated 100 random numbers that has a mean 50 and standard deviation 10. And then I got this data, I sorted them, I constructed histogram, then I compute 1 minus mean minus standard deviation, mean plus standard deviation, and I got these two ranges. After getting these two ranges, now I went back to the original data that I have generated. Then I want to take a look by computing visual computations. I want to match that the data has 68% frequency, which falls between these two numbers. Are you okay or not? Okay, let me conclude these discussions and before going to the next one. If you have a data, quantitative variable or continuous variable, then if someone will ask you, I want to draw a frequency curve, how can I do that? You immediately construct a histogram, then add the top middle point of each bar. The curve that you get is known as the frequency curve. Frequency curve could be symmetric, that means bell-shaped or mound-shaped or normal curve. And within that normal curve, within that bell-shaped curve, what percent of data fall within 1 standard deviations from the mean? That is 68%. What percent of data fall within 2 standard deviations from mean? That is 95%. What percent of data fall within 3 standard deviations from mean? That is called the 99.7%. And I have given you a numerical example by simulating data. I simulated data 100 data that has a mean 50 standard deviation 10. This is the 100 data, and then I sorted them as a B, which is equal to that. This is the ascending order, and then I computed these two range within 1 standard deviations range, which is 40.91 and 59.87. Then I go to the data in here, 40.91, 40.91. It will start from there. 40.91, it will start from there. If I start compute there 1, 2, 3, here is 3, and then there are another 63 and 3 and 3, there is almost 68% of the data falls within 1 standard deviations, which is this. 68% data falls between these two numbers. Okay. Similarly, if I do it for the 2 standard deviations and 3 standard deviation, I will get the same results. Okay.
I have a question.
Yes.
Can you go back to data?
Yeah.
So, like when you give us assignment, right, there was code that we had to put in. Like, how do you know that if, is this like a common code that we're gonna write when we're using something like this?
This is what you haven't learned. This is R.
Okay.
This is what you are going to learn at the end of the semester.
Oh,
Okay, the code that you have used, which is in the Python. Okay,
apart from this one, can we use another apart from that R?
for your exam,
No, like, you know how you use that app to like look for it? Like, we have Anaconda, right?
yeah,
Is there anything we could use to like look for our mean and everything instead of
yeah, there is a R Studio, right?
R still?
Yeah, so that is similar to the R that I have used. Okay. In the Anaconda, there is the R Studio. This is the R Studio, but in Anaconda, there is no R. Base R is not in there. Okay. So now, next question is, after drawing histogram, suppose you did not get the symmetric bell-shaped or mound-shaped curve. Instead, you got the long right tail or long left tail. This is called the positively skewed. This is called the positively skewed or skewed to the right. Skewed to the right. Okay. This is called the negatively skewed. Negatively skewed or skewed to the left. Skewed to the left. Okay, this is called the positively skewed or skewed to the right. So in this case, this is the highest peak, there is always a mod. Highest peak, there is always the mod. Highest peak, there is a mod. I have a data, I construct a histogram and put the frequency curve by adding the top middle point of each bar, I got one of these. Then this is called the top one is called the positively skewed or skewed to the right. And then bottom one is called the negatively skewed or skewed to the left. In that case, where does mean, median, mode stands? Median is always in the middle. Median is always in the middle. And mean is always in the left or right tail. Are you understanding? So previously I showed you normal curve and I told you in this middle part mean, median, mode exists, right? When this is a normal curve, bell-shaped curve or mound-shaped curve, in this case mean, median, mode are the same. But if the curve is skewed to the left or is skewed to the right, median is always in the middle and the highest peak has the mode, and then mean is in the left and right. So what is the real life example? Real life example that you went to collect the data from Beverly Hill area, understand? Beverly Hill area, you went to collect the data from the maybe, okay, from here, when we will get this type of data? Suppose you went to collect the data and you are collecting the data from a Beverly Hill area. In the Beverly Hill area, all people has $1 million of income, right? All people has $1 million of income in here. But accidentally in your sample, suppose some taxi driver, some plumber are included. In that case, mean will go down. That is why this type of curve might appear. On the other hand, suppose you are collecting data from the Macomb area, where most of the people's income is around 50,000, 60,000. But suppose some extremely rich people like Donald Trump got included in the sample, then the mean will go up, right? So that's the reason here extremely rich people are included in the sample. Extremely rich people are included in the sample. Rich, R-I-C-H. Extremely rich person included in the sample. So that is why mean went up and here mean went down, because all of these are really very rich people, but some poor people, taxi cab driver, plumber, some of those included in the sample, so they reduce the mean. Yes.
So it's like the outliers pulling the mean.
Exactly.
Okay.
So outlier is increasing the mean, outlier is decreasing the mean. Extremely rich people got included in the average living area people, and extremely poor people got included in the sample where rich people live. If this is the Beverly Hill area and this is the Macomb area, so then you will end up with these things if rich people got included. In such a cases, what will be the percentage of frequency? What is the percentage of frequency? If your curve is not normal, is not bell shape, is not mound shape, then within one standard deviation, so the formula is 1/1 minus k square %. At least that % of data falls within k standard deviation. Within k standard deviation. If your frequency curve is skewed to the left or skewed to the right, then that % of data falls within k standard deviations. So for example, within one standard deviation, no useful information. Within one standard deviation, no useful information can be obtained. Okay, so within two standard deviation, 1 minus 1/2 square equal to 3/4 equal to 75% of the data fall, at least 75% data fall within 2 standard deviation. And within 3 standard deviation, 1 minus 1/3 square equal to 8/9 equal to at least 89% data fall within 1 standard deviation. Okay? If your curve is skewed to the left or skewed to the right, this rule is known as the first one is known as the empirical rule. This rule is known as Shea-by-Shape rule. Shea-by-Shape rule. Okay. Let me tell you again. If you have a quantitative variable, which could be discrete quantitative or continuous quantitative variable, from that variable you construct histogram. After constructing histogram, you add the top middle point of each bar, then you will get a frequency curve. If your frequency curve look like symmetric, bell-shaped or mound-shaped, then within 1 standard deviation, 68% data falls. Within 2 standard deviation, 95% data fall. Within 3 standard deviation, 99.7% data fall. But if your frequency curve is not bell-shaped, mound-shaped or symmetric, instead, if your frequency curve is skewed to the left or skewed to the right, in such a cases, what percentage of data fall within 1 standard deviation, 2 standard deviation, 3 standard deviation? The formula given by Shea-by-Shape is 1 minus 1/k square. Clear? You understand, right? So last half an hour or 40 minutes, what we discussed, what percentage of data fall within 1 standard deviation, 2 standard deviation, 3 standard deviations from a frequency curve. Frequency curve is obtained from histogram. Clear? So let me discuss few more things from that PDF. Those are the very simple thing. Odds. What is odds? So odds is this: smoker, there are 100%, okay? Smokers equal to 30 and non-smokers equal to 70. So odds of smoker equal to what? Odds of smoker equal to 30/70. Okay? This is called the odds of smoker. So odds of non-smokers equal to 70/30. Okay. What is the probability of smoker? Probability of smoker equal to 30/70, and probability of non-smoker 30/100. This is the probability of non-smoker. So odds can be written in terms of probability. Odds can be written as in terms of probability. This is odds of smoker. Sorry, this is probability of smoker and probability of non-smoker. So that means odd can be written in terms of probability. Okay, which is equal to probability P and which is equal to probability Q. So odds can be obtained in terms of P/Q. Okay. Now odds ratio is what? Odds ratio. So odds of female smoker. So suppose there are 100 female, out of 100 female, so 20 smoker and 80 non-smoker, right? Female, this is female. So female is smoker and this is non-smoker, and this is male. Suppose 200 this is 50, that is 150. So that means 50 and 150. So odds ratio, this is called odds ratio. This is called the female odds of smoker. Female odds of smoker. Female odds of smoker, and that is male odds of smoker. Male odds of smoker. So that means you are finding odds ratio. This is what known as the odds ratio. Clear, right? Odds and odds ratio. Odds ratio is compared between two groups. Okay. Now odds and odds ratio I mentioned in here. Now what is false positive? False positive means this girl went to the doctor. Doctor tested her and gave that you have a COVID, but actually she does not have a COVID. That is called the false positive. Understand? And true positive, what? You have a COVID that is tested out as a COVID. That is called the true positive. False negative, what? You do not have a heart disease, but you do not have a blood pressure, but testing said that you have a blood pressure. That is called the false negative. And true negative is what? You do not have a high blood pressure and it is come out as a true, that you do not have a. Okay, so these are the questions. These are the basics idea. Down the road, you will get all of this. So read all of these documents thoroughly, and so your exam will be okay. 10 questions is coming from these documents. Watch the video, then your exam will not be difficult. Okay. Sorry, I did not give you any break today. So next class we will discuss. Let's see what I can discuss. Maybe I can discuss some probability stuff or maybe R stuff. So do you want to learn? How do you like Python? How do you like Python?
Like it.
Little bit, right? How about you? You hate it, but remember, it will be ultimately it will be paid off. You hate me, but please do not hate Python. You understand? If you write in your resume, you know Python, and all the homeworks that you are doing, keep it as a sample. And when your employer called you, ask you, could you give us a sample of the code that you have written? Then you can say, you can send them. This is the homework. Understand? Which one?
A Word document.
This?
Yes.
You're going to upload the Word document?
What document? That one accidentally.
Of your working is the one you were doing in class.
Yeah, the one that I write in the class from the very beginning today.
No,
That was.
No, the one slide, the one you were showing. No, but yeah, this one.
No, just go down to the on smart.
When did you just take a
Okay.
picture?
Yeah, I'll take a picture. I'll call you and say this. No. Okay, let's do that. Okay, thank you.
Okay.
So we'll go see if I understand.
You understand how
I
I-
don't.
That was the one.
Like, you asked.
I showed you like.
Oh, okay. So I didn't-